Okay, hi folks. In the video, in the YouTube channel, I have several video segments, tutorials for parameterizing and creating design tables for a single part. The specific thing that I'm interested in is actually design table, but I've done it only for single parts. So what I would like to do is extend that to creating design table for assemblies. The problem that I want to do is right on the screen. You can see that it's made out of two pieces. One is the base that you see there with the parameter alpha and h, and there's a plane of symmetry there. And the other one is the wedge on the right side, upper right side, which has three parameters: alpha, beta, and h. Now I want the two alphas are obviously to match and the two h's to match. Let's go ahead and see how we do that. I'm not claiming that this is the only way of doing it. This is the best way of doing it. In fact, if you use copy and paste special, as a result with a link, you can cut down on some of the steps. But I'm going to do it by brute force. Okay. So let me go ahead and start a Catia product file. Oh, cancel. Sorry. File new. Product file. And right away we're going to insert, save this thing, file, save management, save as. On the desktop, create a new folder. I call design table for assembly. All right, so everything is going to go in there. So insert a new part in there, and this is going to be my base. Right click properties and change it to base and base. This is the instance name, and this is the actual part name, part number in Catia. Okay, let's make it on a convenient plane. On that vertical plane, I will sketch. We'll sketch that shape at the bottom. It doesn't have to be very accurate right now. We can always put the appropriate constraints on it in a minute. Okay, what do we want? We want this thing, this control that, to be symmetric with respect to that axis. Okay, and we want this point, control that point, also to be symmetric with respect to this axis. All right, and let's put the dimensions that we're going to be controlling later on. So this angle eventually is going to be alpha, and the vertical distance, so from this point to that edge, this is going to be h later on. Okay, exit, pad it. Let me pad it by one inch because it's not a parameter anyway. Since eventually I'm going to make the name of these things parts change on the with the design table, the material change, I'm going to put a dummy material here on this particular. Let me go to this part. Put a dummy material there. Metal, aluminum on that part, and say OK. Good. Now let's go to product. First of all, save everything before, and then we're going to insert the second part. So insert a new part in there, and this is going to be the wedge. Right click properties, wedge, and wedge. Okay, let's make it. Double click on that on a convenient plane, on that same vertical plane. I will sketch. Alright, remember I said that I'm going to do this thing by brute force. There are easy ways of doing it. So there we are. Okay, let's first make it symmetric. So left point, control right point, control, oops, no. Left point, control right point, control middle axis. We're going to make it symmetric. Okay. And then we need some dimensions. So this is going to be eventually alpha, which is going to be equal to that, okay? And this is going to be eventually beta. And the distance from here to there, but the vertical distance is going to be eventually equal to this guy, which is h. Okay, exit and pad it. Where's the pad? 1 inch. Okay, good. So let's put a dummy material on it. Metal. Obviously, it doesn't have to be aluminum, but I can. Alright, well, I want to put aluminum on it, on that part. Eventually, the table is going to determine what it's going to be. Very good. Save everything. Oops. File. Okay, you go to the product and save everything. Or file, save man. Okay, so now we're going to make sure you are at the assembly level, the rest of these. Don't go to these parts. Make sure that you are at the assembly level. Okay, that can get you into trouble if you actually happen to be in one of the parts and do some of these things at the assembly level. Okay, so click on f of x. All right, so let's see now. Let me move this thing on the side. All right. So click on the product. All the dimensions that you created are going to appear. Let me see now. The independent one. This is from the base. You can see that. I'm going to call this thing alpha. Okay. Currently it has value 69. This is going to be from the base. And currently it has value 59. I'm going to call it beta. Okay, good. Now, I want this angle, which are called alpha incidentally, to be equal to that angle, or this angle to be equal to this more. I can say this is equal to alpha, but that's not how I'm going to do that. I'm going to select this angle from the wedge and say add a formula equal to that angle from the bottom. So because this was called alpha, if you ever change alpha, that guy is going to change. Say okay. And you want to select this height. It is true that it's equal to h. I understand that. But I don't want to do it like that. I want to say this is equal to that. So every time you say you change this, which incidentally I will be calling h, this is going to change. Okay? So add a formula equal to that fellow. Say okay. And incidentally, this is what we wanted to call h. I should have done it when I did alpha and beta, but it's okay. We can do it now. H. I make uppercase H. Okay. Now, first of all, this thing came out to be red, and the reason it's red is because we made an equation, and it's trying to adjust it. So if you say update, it'll be okay. This will fit that, for sure, okay? Because this is alpha, and this angle is equal to that angle, therefore this is alpha. All right. Now, at this point, we can go and create our design table. Here are the equations that we created. These are the two equations. These two angles always match, and this height always matches the height over there. So now we're going to click on design table. It says, do you want to create it from a pre-existing file? The answer is, of course, no. Do you want to create design table with current parameters? The answer is yes. And we say, okay. And then it says, okay, what do you want to put in that design table? I'm going to say rename parameters. Notice that at the assembly level, there's only 3 parameters. For the base alpha and h, and for the wedge beta. So all 3 of them. And the order, I said I want alpha to go first. Okay. I want beta to go next. The table that I showed you looked like that. What can I do? Right here. Where's the table? Right there. Alpha first column, beta second column, h third column. Okay. And then we say okay. Good. So where do you want to put it? Well, I want to put it in that same folder, design table assembly. Remember, on the test, when you give me a file, a part file or an assembly file, you have to give me the associated design tables. Otherwise, you won't be able to see it. I'm going to use the same name. Okay, just be patient. Just creating that Excel spreadsheet for the assembly. The steps, as you see, are identical with the part, the design table for a part. The only thing is that when you do things, they better be at the assembly level, otherwise you get into trouble. Okay, there we are. These are the current values. So edit table. Let's put our new values. And incidentally, I'm going to put some additional columns here, or maybe we do that later. Okay, let me put first of all some other numbers here. So the alpha of the base, you make it 45. The beta, which is on the top, also 45. Well, actually, let me make it 90. 90. And the height, I'm going to make it 1. Now, if you put random numbers here, because the other side, the other dimensions are not parameterized, you may screw up the sketch, so be careful. So 90 here, say 30 there, and a 0.5 there. I'm going to save this, and you have to close it. And you get the synchronization message. Okay, let's see. For example, if we go to the second row, as long as I did not put some bad numbers there, apply and update, notice that they changed, and they changed the way they're supposed to. This angle matches that angle. The beta was 90 as I selected it, and the height, this height is 0.5. If I make the 1, this height is 1. If I go to the next one, apply and update, because my automatic is not set. Okay, a couple of things I'm going to tell you. One is, let's close this for a second. Make sure you have assembly constraints, because on the test, if be a problem, I'll make sure to say that assembly constraints should be met. So what are the assembly constraints? For example, I want this plane to be coincident with this plane. I want, for example, this edge to be coincident with this edge. And let's see, I want also, let me turn this thing around. This edge to be coincident with, my middle mouse button is not working, so this is why I have to use these icons here, which I don't really like. Okay, so there, and then update. All right, so assembly constraints are created. If I move these things, rotate everything, and update, it should go back to the original position. Hopefully I haven't forgotten anything. Now, the next thing I want to do is I want to add, modify that table so that you can change the materials on it. Now, first of all, notice that the design table must appear on your screen, and I've shown people how to do this thing. You go to Tools, Options, Infrastructure, Product Infrastructure, and take the top tab all the way to the end, which I think it says Tree Visualization, and then you make sure the relations are active and the probably parameters active, if you have any parameters. Now, okay, so you double click on the design table. All right, edit the table. Over here, I'm going to insert two columns. You'll see what they are. Insert another column, and two more, and two more. The first one is going to be base name. Base name. I'm going to call it base name. Okay. And then base material. Base mat. And then wedge name. And then wedge material. Okay, let's put our names here. So I'll call it B1, B2, B3, B3. I don't know what I had here. I'll make it brass, gold, iron. Okay, wedge name, I'll call it W1. These are random names that I'm picking. W2, W3, and for the material, also brass for the first one. For the next one, I'm going to make it steel, and for the last one, I'm going to make it copper. How about that? All right. So you save it, you close it, wait for the message to appear here. Now, notice that this table did not change here, because if you go to the association tab, what it's telling you is that, wait a minute, I don't know what to make out of these. For example, base name, I want it to be the same as base part number. So let's scroll down. Let's find the right here, base part number. I want these two to mean the same thing. Associate, good name. Okay, and then I want the base material to be the same as whatever dummy material that I put in there. So let's see if we can find it. Base. There must be a material somewhere here. My guess, I'm looking for something called mat, but I cannot find it. I can try it. Maybe this. I'm not sure though. I'm not. Ordinarily, you see material, but I don't see it there. So let me click on this. Yeah, it must have been that. Let's see now. Try. This was the base, right? Yeah, base. This was the base. Remember, the name is changed because we associated that manually. But let's try this. Let's try. Let me try definition. I don't know. Let's see now. Okay, wedge name. So that's going to be wedge part number. Wedge part number. Let's go to the top level. Find wedge part number. Which is right there. Associate these two. And then finally wedge material, which I'm hoping that it's this. I'm not 100% sure, but we'll find out. Wedge, maybe definition. What? We can check. Let's check our configuration. Did it work? Oh yeah, right here. It did work. Okay. It is that definition. I didn't realize that it was not same material. And notice that what happens is that if you go to the first one, that's the default one that you made, and of course the name changes, B1 and W1. If you go to the next row, the name changes, B2, W2, the properties become, well, I suppose we have to update it, so we say apply. Where's the update here? Update, let's try this. No, that material did not change. So I'll leave it to you to figure it out. You see that definition. Well, actually, let's check that. Let's check one more time. Let's go here. You see, the table is okay. The table is okay, but the actual material is not changing. And apply, okay, and update. Yeah, so it can't be that definition that I selected because these are not changing. Let's give it another couple of minutes. Maybe we can figure it out. I'm not sure. Let me double click on this, and under edit table. Oh, no, under association. No, these were changed. There's no problem there. Okay, so under association, let's scroll down and see what is it that we can find here which resembles the material. So if you go there, that's okay. So if you go to B3, uh, the material, I want to find the material here, and I cannot find it. Okay, so I will leave this thing as it is because I failed in making the materials change. Okay, everything else is okay. Everything else is okay. When you select this and you apply and you update, everything changes the way it is except that these materials are not changing. I thought it was definition, but it sure doesn't look like it. Let's try one more thing before we quit. I'm going to click on this. Okay, click on that. Click on the product to see whether I can sort it out some other way. Let's see now. Can we sort this out by strings? Let's see. Sort it out by strings. Part number, nomenclature. This definition is B2. It looks like these don't understand each other. So I'll leave it the way it is. Hopefully I'll figure out what the problem is and I may do another video table. Okay?